Hello students, I am Dr. S.B. Tuljapure, Associate Professor, Department of Mechanical Engineering, Walchand Institute of Technology, Solapur. So in the today's session, we are going to deal with maximum suction height or lift for centrifugal pump. The learning outcome. At the end of this session, students will be able to derive an equation of maximum suction height for centrifugal pumps. Now, let us first see what is meant by suction height. Then further, we will go for the derivation which will give us the maximum value of the suction height. So as the term it is containing two words, it is suction and height. So the firstly, let us deal with height. So when we are saying height, so it is the vertical distance. Okay. So whenever we say distance, it is going to be between the 2 points or two sections. Okay. So now the first word it is the suction. So suction height in case of the centrifugal pumps, it is nothing but it is the vertical distance between the free surface of the liquid in the sump or reservoir and the center of the centrifugal pump or impeller. So the distance between free surface of liquid and center of the impeller. So this distance should be taken as vertical distance. So this distance is nothing but it is called as suction height. Looking towards this diagram, so we can note that firstly we are having this free surface of the liquid in the sump or the reservoir. Okay. Then the impeller, the center of that one. So one center line it has been drawn. Okay. So the vertical distance from the free surface of the liquid to the center line of the impeller. So this distance, this vertical distance, it is called as suction height. Okay. So in case of ours, we are interested in a derivation, so which is going to give us at the end the value of maximum suction height. That is one formula we are going to get, which will give us, by making use of which we can go for the calculations, and then that will give us the maximum suction height value. Okay. So now we are saying that we are interested in maximum suction height for the centrifugal pumps, etc. So the question comes to the mind, why we are going for the maximum value of the suction height and not the minimum, or say in case of that one medium values, or what is the importance of this suction height, so that we are dealing with that one, that is we are trying to go for one equation which will give us the value of the suction height first, then the conditions which will lead us to the maximum value of the suction height. Like that we are proceeding. But why we should take interest in maximum value of the suction height? So think about this. Okay. Let us see the answer of this one. So by knowing the value of maximum suction height of centrifugal pumps, we can install or mount the centrifugal pumps much away from the sump or reservoir, making it convenient for maintenance and safe to use. Okay. So if you think of a well in which we are having the water, and then the water in the well, it is to be lifted with the help of these centrifugal pumps. In case of that one, we are generally mounting the centrifugal pump at some of the platforms inside the well only. Okay, so we can't take or we can't install the centrifugal pump outside the well and suck the water and then lift it to a particular, say, deliver to a certain tank or give it to the farm, etc., like that. So that is not happening. So the pump, it is mounted on some platform which is available inside the well only. So think of, if the increase in the water level takes place, in case of that one, the centrifugal pump along with the motor, etc., it will be completely inside the water. So what we should try for it is, say, it should be mounted as at a larger height as possible. Okay, so in case of that one, we should know what is the maximum value of that suction height, so that it will be easier as to mark there and mount that centrifugal pump at that particular extreme condition, so that, so to some extent we can allow the increase in the level of the water in the well. Now let us go for the derivation of the maximum suction height. Okay. So here we are going to make use of the Bernoulli's theorem. So as you are knowing, Bernoulli's theorem is associated with the different types of the energies, and we are going to have the three different types of the energies in case of the fluid flow: pressure head, and then kinetic head, and the datum head, and summation of these need to be constant. Okay, so we are now finalizing two sections. One section, it is going to be the free surface of the liquid itself. The second section, it is going to be at the center of the impeller. Okay, so applying the Bernoulli's theorem at section 1 and section 2. So firstly, P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus the head loss which is occurring, that we have written. Okay. Now at the free surface of the liquid, so whatever fluid particles are there, okay, so unless and until they enter the suction pipe, the velocity will be 0. Okay, so V1 is equal to 0. So considering the datum passing through the section 1, we are having the value of this Z1 as equal to 0. Then at the free surface of the liquid, we are having the pressure as atmospheric. So putting the value of the P1 as equal to, say, it is atmospheric pressure PA. So in case of the section 2, we are interested in again the different values. Okay, so in case of section 2, we are having, suppose, P2 by rho g. Okay, so P2 by rho g, it is the at pressure head at the center of the impeller. Okay, then we are having the V2 square by 2g velocity head. Okay, then Z2. Okay, in case of the Z2, say, see that if we are considering the say datum at the section 1, Z2 will be equal to nothing but it is the suction height. Okay, so it is HS. Then the head loss HL, in case of that one, so it is nothing but it is the frictional head loss which is occurring on the suction side. So HL will be equal to HF actually, and at the suction side it is S. So HFS it will be. So putting these all values in this equation, so we are going to get it as, so it will be PA by rho g, that is P1 by rho g will be replaced by now PA by rho g. So these two parameters, these are 0. Then this will be equal to, then it is P2 by rho g plus V2 square by 2g plus Z2 is nothing but it is HS suction height, and then the head loss is equal to it is HFS. Okay. The same equation I have taken in this slide. Okay. So now we are interested in firstly the formula of suction height, and then we will go for the condition for the maximum suction height. So keeping only HS on one of the sides, so all the parameters are taken on the other side. So HS comes out to be PA by rho g minus P2 by rho g minus V2 square by 2g minus HFS. So for this is the equation with the help of which we can determine the suction height. But we are interested in the maximum suction height value. So HS max can be determined. So by using the condition that HS can be maximum when we can have this lower value of the P2 by rho g. So P2 by rho g should be minimum so that HS will be maximum. But P2 by rho g, the lowest value is having some limit. So P2 by rho g can't be lesser than PV by rho g of the liquid, that is the vapor pressure head of the liquid. Okay, so let us see what happens if it goes below the vapor pressure head. Okay. So if the pressure at the center of the impeller is lesser than the vapor pressure, in case of that one, the liquid gets converted into the vapors or the bubbles. So when these bubbles are carried to the high pressure region, the bursting of these bubbles occur, and during the bursting of the bubbles, erosion of the inner surface of the casing takes place. So during that, the noise will be there and the vibrations are going to be there. Okay. So to avoid that one, what we should do is we should take the extreme value that is allowed, that is at the center of the impeller, that is P2 by rho g should be equal to, at the most it will be PV by rho g. So taking P2 by rho g equal to PV by rho g, that is the vapor pressure head, and also replacing V2, that is the velocity at section 2, is nothing but it is velocity of the liquid in the suction side. Okay, so it is V2 by Vs we are going to replace. So Hs max, it comes out to be Pa by rho g minus Pv by rho g minus Vs square by 2g minus Hfs. So this is the formula with the help of which we can calculate the maximum suction height, and this can be utilized for mounting of the centrifugal pump. So maximum height from the free surface of the liquid to the center of the impeller should be, so it is given by this particular formula, and should not be larger than that one to avoid the cavitation. These are the references used for this particular session. Thank you.